In this video, I'm going to discuss color theory. Unfortunately, this section is going to have a lot of vocabulary, but the terms are not overly complicated. Hue is the color family, such as red, orange, yellow, green, blue, violet, etc. Value is the light or darkness of a color. So the lighter the color, the higher the value, and the darker the color, the lower the value. A color like yellow will have a higher assigned value than a dark blue. It's important to use a variety of different values in your maps and graphics you create, not just in this class, but as a general rule. The tone of a color is created whenever you add gray to it. Shade is changed when you add black, and tint is changed when you add white. I was trying to think of a way to help you remember which color is added to create which effect. I spent way too long thinking on it, so please do not judge my memorization strategies. Okay, so when you're growing up, or maybe even now, who am I to judge? I think it's safe to say that you fought with your parents or another older authority figure. Maybe they said, "Now don't you take that tone with me." And because they're older, their hair may be gray or graying. They may even tell you that you are giving them gray hair. So, whenever you are trying to remember what tone is, think, "Don't use that tone with me, old gray haired person." When you are trying to remember the difference between shade and tint, think about the windows in your home. If you think about your car, you will confuse yourself. So, if you have blackout shades at home to make the room as dark as possible, then you are adding black. If you are super fancy or live in an apartment complex, you may have privacy windows, which are tinted white or have some weird texture that makes the light coming in from the window appear a solid white to avoid any potential embarrassment. So tint is white and shade is black. Moving on. Saturation, chroma, or intensity are all the same thing. The color quote-unquote purity are located at the edge of the spectrum. It can be intense or dull. Monochromatic is a variation of one color and changes the value of saturation, like the rose in the image. Historically, color theorists believe that the three primary colors of red, yellow, and blue could be mixed to make all possible colors. At least that's what I learned in grade school. We have come to find out that that is not necessarily true. I'm going to discuss the terms in this slide with examples, but I wanted you to have a list of terminology to work from. There are two primary color wheels in the slide here. The first is the most traditional, consisting of red, yellow, and blue. Note that the text below says that red, yellow, and blue are pigment-generated colors. That is unlike the second primary color wheel that has red, blue, and green in it. Those colors are generated from light. I will go more into detail about that in a moment. But the primary colors are the first stage. So these are going to give a value of 1. Now, secondary colors are just mixtures of the 3 primary colors on the wheel with the colors next to them. That makes 6 colors instead of 3 and is the second phase. Tertiary colors come from the Latin word tertiaries with the root tertius, meaning third, and arius, meaning rank, coming together to form of the third rank. All of that to say, tertiary is the third phase. Tertiary colors are created by combining secondary colors with primary colors. This is where colors like red, orange, and blue-purple come into play. This can expand even into quaternary or fourth level and beyond. So at tertiary, you have the third level, and you are adding the first one and the second level. So 1 plus 2 equals 3. Complementary colors are colors that sit across from each other on the color wheel and complement each other. In color theory, they cancel each other out to make white or black, but again, I will discuss that a bit later. Analogous colors sit next to each other on the color wheel, like red, orange, and yellow. One color will be dominant while the others will support each other in appearance. Triadic colors are evenly spaced around the color wheel when broken into thirds. These groupings are usually bright and dynamic while creating harmony, both visually and contrast as well. Triadic and quadrilateral color schemes use two sets of complementary colors. It's best to try to choose pairs where one color stands out among the rest, but that may prove difficult. Split complementary color schemes are based off a single color and then uses the two neighbors of its complementary match. You do not need to memorize these terms, it's just a way for you to come up with your own color palettes. There are several different properties of color, but in this slide, what I want you to primarily focus on is the differences in color intensity based on the surroundings of the color around it. White and black are traditionally easy to use to display intense colors because of the high amount of contrast between the two. Don't write anything in this slide down. In modern color theory, there are two primary ways to make color. They are additive and subtractive mixing systems. Do not think about the names just yet. Now, don't go rewinding the video just to write those other words down in your notes. Trust me. So, one system produces color through light on a screen, like your computer or TV. The other makes color with different pigments or ink, like when something is printed, painted, or drawn. Okay, so think back to a few weeks ago when we learned about the electromagnetic spectrum, also known as the spectrum of light. Our eyes allow us to see by interpreting the light waves that enter them. The two main properties of light that I wanted you to understand for this class are absorption and reflection. Absorption is when a surface sucks in certain wavelengths and keeps them for themselves. Reflection is the opposite. Reflection occurs when certain wavelengths hit a surface and bounce right back off. I imagine it looking something like racquetball. White and black are both pros at these, but each a different one. Black is a pro absorber and white is a pro reflector. Black surfaces absorb all visible wavelengths and white surfaces reflect all visible wavelengths. So, when you see an object that is black, it's because your eyes are not receiving any wavelengths back from that object. That's why black cars and surfaces are always much hotter than white surfaces. Light is energy and heat is energy, so when an object absorbs more light, its temperature often increases. White objects are pro-reflectors because they do not want to have anything to do with light, so they just get rid of all of it. So the white surfaces reflect all visible wavelengths and shoot them back at your eye, like hot potato. Light, no thank you. I don't want it, you can have it. That's why you should still wear sunscreen on cloudy days or when you're on the water or in the snow. All that light is being reflected back at you. And I don't know about you, but I do not want to have skin cancer. Anywho, back to the example on the left. Color created through light, like with a computer screen. So, if color is formed with light, then we must begin with no light. The object, like your TV or computer screen, is black when it's turned off, right? But when it's turned on, it has light, and it uses red, green, and blue lights to make all of those different colors by mixing them within various combinations. When they are all added together, they make white light, which makes sense because white is all visible wavelengths, or all colors combined. Moving on to the example on the right. If you're going to print or paint something, you generally start with a white surface so you can best show all the different colors. The same is true here. Now, say you're working for the government on a super secret project. The if I told you I'd have to kill you kind. Well, you're a good person and murder really isn't your thing. However, this is also the 80s, so all of the information is printed on paper. So, in order to avoid having to murder anyone, you want to block out certain portions of the text that would give away any secret information and therefore cause you to have to murder someone because they saw something they shouldn't have. Well, how are you going to do that? By covering it in black, of course. Why black? Because black is the combination of all colors, so nothing would be able to be seen through the paper, even with slight variations within the color. You aren't trying to highlight it, you are trying to redact it. Then your boss calls you and asks you if anyone has seen the documents that shouldn't have, and you respond with one word: negative. This has a point, I promise. As I said before, in modern color theory, there are two primary ways to make color: additive and subtractive mixing methods. When you combine all colors in an additive method, you end up with white because you're adding all the light sources together. All of those different wavelengths make their way back into your eyes, adding the information to your brain that identifies the color as white. With subtractive methods, you combine all the pigments to come out with black. Although subtractive methods are created with pigments, you still need light in order to see them. If you don't have light, you're just in a dark room. But because you are looking at pigments that when all mixed together form black, there is no light coming back from that black spot. In effect, it has removed or subtracted that light that could have possibly been reflected back into your eyes, therefore making it the subtractive method. Okay, so here we have three different color schemes: CMYK, RGB, and RYB. RYB is the traditional theory of red, yellow, and blue and how they all combine to make all colors. CMYK is a subtractive theory that we just talked about, and the best way to remember that is thinking about your printer and the ink. It has cyan ink, magenta ink, yellow ink, and black ink. RGB is the additive colors, and those are what are used in your computer screen. Hex is a additive color scheme like RGB. All it does is it creates a six character code for you to use on your computer whenever you're creating maps or images or anything of that nature. It's just the code representing the color. And here is an extra graphic to help you understand color theory. So that is all I have for you for color theory.